Alright, so hello and welcome. Here we are. We are going to go ahead and solve a Hackerrank problem. Actually, a few, I think. Spend like an hour, just spend some time. Before we get going, just want to make sure this is working. Yeah, oh man, oh. Body feels like it's falling apart, man. I think I need to change how my setup is put together and stand basically instead of sitting, and then also I gotta do something about my bed too. So stand, set up my bed so it's more comfortable for my back and my neck. Excuse me, and also start exercising again. I've been kind of not exercising for a while just because I don't know, man. I get into like very chaotic situations, I guess, and I don't exercise because of that, and it's like not a good excuse. But yeah, I've like been not exercising for a long time, which is really bad. But I'll figure that out at some point. For the time being, I figure I'd take a week or two more. It's been like a few months now that I haven't been exercising, but I think it's okay. I've been under a lot of stress, I guess, so I think I'm okay to just kind of take it easy, not try to focus too much on trying to exercise. All right, so an array is a simple data structure used to store a collection of data in a contiguous block of memory. Each element in the collection is accessed using an index, and the elements are easy to find because they are stored sequentially in memory. Because the collection of elements in an array is stored as a big block of data, we typically use arrays when we know exactly how many pieces of data we're going to have. For example, you might use an array to store a list of student ID numbers or the names of state capitals. To create an array of integers named myArray that can hold 4 integer values, you would write the following code. Int my array, new int 4. This sets aside a block of memory that's capable of storing 4 integers. Each integer storage cell is assigned a unique index ranging from 0 to 1 less than the size of the array, and each cell initially contains a 0. In the case of my array, we can store integers at indices 0, 1, 2, and 3. Let's say we wanted the last cell to store the number 12. To do this, we write my array 3 equals 12. Similarly, we can print the contents of the last cell with the following code. Print line myArray 3. The code above prints the value stored at index 3 of my array, which is 12, the value we previously stored there. It's important to note that while Java initializes each cell of an array of integers with a 0, not all languages do this. Yes, true. I actually had an interview, C++ interview, where I forgot to initialize a null pointer and it crashed while I was interviewing, and I was upset. It's really frustrating. Code in your editor does the following. Reads an integer from standard and saves it to a variable n, denoting from some number of integers. Reads n integers corresponding to a sub 0 to a sub n minus 1 from standard in, and saves each integer a sub I to a variable val. Attempts to print each element of an array of integers named a. Attempts to print each element of an array of integers named a. Write the following code in the unlocked portion of your editor. Create an array A capable of holding n integers. Create an array A capable of holding n integers. Modify the code in the loop so that it saves each sequential value to its corresponding location in the array. For example, the first value must be stored in a sub 0, the second value must be stored in a sub 1, and so on. Good luck. First line contains a single integer n, denoting the size of the array. Each line I of the n subsequent lines contains a single integer, denoting the value of element a sub I. Oh, my neck is killing me, man. Output format. You are not responsible for printing any output to standard outlock code in the editor. Loops through the array A and prints each sequential element on a new line. Okay. Save each integer to its corresponding index in A. We get A equals 10, 20, 30, 40, 50. Locked code prints each array element on a new line from left to right. Okay. So, what do they want us to do? Prints each sequential element in array A. Okay, so they want us to create a new int array A. to scan that in, right? So oh boy. Whoa. Keep putting my finger in the wrong spot. Something like this should do the trick, right? That's what they want. Oh. Ah. Try that. I think that's what we want. Okay, that's good. Great, keep going. Fair enough. 6x6 two-dimensional array, an hourglass in an array is a portion shaped like this, A, B, C, D, E, F, G. If we create an hourglass using the number 1 within an array full of zeros, it might look like this. Actually, there are many hourglasses in the above array. The 3 leftmost hourglasses are the following. So we have the I's, or the 1s rather, then you have 1, 1, 0, with a 1 here, 1, 1, 0, and then 3, 0, 0, 0. Why isn't this last one an hourglass? Sum of an hourglass is the sum of all the numbers within it. Some of the hourglasses above are 7, 4, and 2 respectively. Oh, okay, that might be why, because the last one would be zeros. In this problem, you have to print the largest sum among all the hourglasses in the array. Okay. Exactly 6 lines, each containing 6 integers separated by spaces. Each integer will be between -9 and 9, inclusive. I think I get it. So you calculate the hourglass, each hourglass sum, and then take the largest. Print the answer to this problem in a single line. I think I get it. It's considered an easy one. Okay. Sure. Excuse me. All right. Fair enough. So we're going to write a routine for an hourglass summation first. Now we want that to be a private subroutine. I'll call it private static hourglass sum. And we're not going to do very much checking in terms of like bounds checking, I guess, which I would normally do for something like this. No, not that I would normally do it, but you would want to have something like that. But because it's a private routine, we won't do that. It should be fine. Nothing. No one else is going to call this, so we kind of know what we're getting ourselves into when we call this routine. So that's interesting. So this becomes an array. Oh, I see. That's how you do it. So a list of integers, it's an array list. And then in that array list, you can push other array lists. So that's how you do it. Okay, I wasn't sure. When I was doing this before, I tried to make a new array list of array lists. And I was so confused. How come we can't do something like list integer test equals new array list of what does this give us? Oh. Okay. But this doesn't work. Yeah, that's interesting. Okay, fair enough. I get it. So, all right. So we have an array, list of lists of integers. And we're going to say int index. Row column. We're going to do row column. That's better. Yeah. So for a particular row and column, we're going to perform an hourglass sum, which is going to be int ret equals 0. we're going to say first row is going to be array.get row, get column, and the column is going to change over loop over I, and we're going to add it that way. Then we're going to say plus equals array.get. Now the row increases by 1 and the column increases by 1, right? That's the middle of the hourglass. Middle of the hourglass. First row of 3 values. Summed. And then finally the last row. Counted for. Same idea. And now it's row plus 2 in every case. And we're going to get column plus I, turn red. So we're going to compute the hourglass sum at each point. And we're going to excuse me. All right, fine. Find the largest hourglass sum. Ret equals 0. Actually, the largest hourglass sum could be. There is in Java. There is an int min. The largest, I guess we do integer min value. Actually, I don't know. Hold on. There is. I have a hard time keeping my thoughts straight here. Okay, that's an integer. All right. What am I even saying? I don't remember. Yeah, there's a way in Java to get the minimum value. Because our hourglass sums could actually be negative, so we don't want to start off with 0. We should just start off with the smallest possible. And if we can get anything, then it'll automatically replace this, unless it is itself the smallest value. But I think we could always start. There is actually a limit. There's only 7 numbers, and the smallest is -9. That means -63 is the smallest we can have. So we could just start off at -63 also, but int min value works too. So we're going to say row column. So the row is the first row, and because we know our hourglass has 3 rows, we can't go to n. We must go to. If we went to n, we'd have 2 rows over. So we need to go to n-1. We just have 1 row hanging off the edge. If we go to n-2, then or less than n-2, really be n-3. Then those 2 extra rows wouldn't be hanging off the edge. That's the idea. So yeah, so 1 row is on n-1, or rather 1 row is on, well, less than n, but we'll say n-1. We'll say 1 row will be on n-1, so we move up 2 rows to make sure that the other 2 rows can fit also. So there will be 1 row on n-3, n-2, and n to n-1. That's the idea. Similarly, for the columns, because we're moving across 3 columns, we have the same idea. The column's got to be less than n-2. And then we can say int hourglass value is going to be hourglass sum of row, column, and this array here. Right. Assuming this works correctly, I'm not going to necessarily modify this code. And then we say if hourglass value, oops, else. If this is smaller than what we're going to return, then we're going to update our return value. And then that's it. All right, how do we do? Oh. No kidding. And it's 6, right? I mean, really, we know that already. We don't really need to. Oh. Oh. I'm sorry, it's supposed to be larger, the larger number. That's my mistake. I want the largest one, not the smallest one. Yeah, I guess we just set n equal to 6. I don't know. I mean, we could make that a constant, static constant as well. Static const final. We should. Just square length. That's really what this should be. Because this is a square matrix. Hopefully this works correctly. There we go. All right, let's go for it. See how we do. Hey, you got there. Very good. Okay, define the following. A subarray of n elements array is an array composed from a contiguous block of the original array's elements. For example, if array 1, 2, 3, then the subarrays are 1, 2, 3, 1, 2, 2, 3, and 1, 2, 3. Something like 1, 3 would not be a subarray, so it's not a contiguous as it's not a contiguous subsection of the original array, although it is a subsequence. The sum of an array is the total sum of its elements. An array's sum is negative if the total sum of its elements is negative. An array's sum is positive if the total sum of its elements is positive. Given an array of n integers, find and print its number of negative subarrays on a new line. The first line contains a single integer n, denoting the length of array A. Second line contains n space-separated integers, describing each respective element A sub I in an array A. Okay, print the number of subarrays of A having negative sums. Actually, there might be a more efficient way to do this, by the way. I don't actually know. I'm going to do this in a way that's quadratic, but there might be a better way to do this. Yeah, so yeah, we'll do a quadratic one. So scanner, scan, or CSC, new scanner system.in, some file IO, and we're going to say, yeah, I know of a way to do this in quadratic time, but I don't know if we can do this faster than that. There might be a way, but I don't know it offhand. I don't really think about it either. So 5, we read 1, so we'll say int n equals c.nextInt, and then we're going to say for int I equals 0, I is less than n, we're going to we'll use an array list, integers, we'll just say array, new array list, integers, say array dot add sc dot next int, and then we're going to say parse inputs. And now we're going to pre-process the array. So the pre-processing step is basically a summation. Sum, or what would you call this, cumulative. And we're going to say for int I equals 0. So actually you probably want to initially dot add array of 0. Now we're assuming it at least has one value, so we don't need to do that check. So we can just say array of 0. And these are lists, so we're going to get 0. And we're going to say I equals 0 to array dot, now it will be size minus 1. I'm going to say next val is going to be cumulative of I plus get I plus array dot get I plus 1. Ooh. Sorry about that. And we're going to say cumulative dot add next value. Okay. So this is pretty much the previous value plus this next value, and then this that gets updated to the next value. There's another way of doing this. It's you basically just say set I plus 1 to, like, there's another way to do it. We'll just say there's another way of doing this. You could alternatively, like, allocate the space for this array first and then set the values accordingly. Actually, I don't need to do this with array lists. You could just use regular arrays, which I'm tempted to do. That might be better, actually. I'm thinking about it. I actually kind of prefer that. Well, yeah, okay, sure. I don't know. I don't know what to call this cumulative array. Now it's the length minus 1. And now this actually looks like the following. Cumulative of I is going to be cumulative, it's I plus 1, of I plus array of I plus 1. Okay. Now, when you want to calculate subarray sums, really you'd want like a lambda expression here, I suppose. You probably could, I guess. You could say something like lambda expression calculate subarray sums. And it looks like the following. So I don't know how exactly you have lambda expressions shown in Java. How are we doing? How are we doing? Excuse me. Okay, so you can use this. Something like, but how do I, the question I have is, like, how do I name my lambda expression? Int x is going to be, or really it will be int, like int a and int b, and what we're going to do is return, it's going to be cumulative of b minus cumulative of a plus array of a. That's what we return. But I want to name this lambda expression. Can list predicate consumer. Function. That's kind of what I want. Function of int integer to xy. Can I take a function that has two, that uses two excuse me, it takes two inputs and returns one output? Oh, my neck. Oh. Not sure what it means really to don't serialize it, it says. Okay. I think serialization is usually to, like, it's like a kind of form of compression and even a way to like transmit data over a connection. It's a form of compression, and you can transmit data over a connection and deserialize on the other side. But what I'm looking for is function with more than one parameter Java. A functional interface with multiple type parameters. Excuse me. Well, what's the point of that? I mean, we could do that, but I really don't want to do that. If you have limited types with multiple parameters, I just want one. Function 6. Nice. Interesting. Interface function 6. Public apply. And that's what happens, I guess. Huh. I don't know, man. by function. Is there a by function? That's only Java 8 though. I think we're in Java 7. Yeah. We go to Java 8, I guess. Oh, okay. All right. Oh no. Didn't mean to lose my code. Okay. So I have a by function, and it's going to be integer A, integer B, into integer. Yeah, 3 integers. Integer wrappers, it's going to be A, B, and return cumulative A, B, Q minus cumulative A. So it'll look like the following. And we're just going to say subarray sum. There we go. First Lambda expression I've used in named Lambda expression that I've used in Java so far. So now we can say for int I equals 0, I is less than. It goes all the way to the end. So I think we said n is the size of the array. Plus I. Int j equals, should be from I to j is less than n plus j. And we're going to say subarray sum of I, j, int val. And then we say if val. Now this is the number of negative subarray sums we want. Okay. So we can just say int count 0 and print 9, right? So if val is less than 0, then increment the count, and at the end of it we print that count. And how do we do? Compilation error. Excuse me. Where's that function that we... Okay. Excuse me, just mapper. Oh, we don't necessarily have a return value, it's just written like so. That doesn't seem right. Really? Can I find by function? Java.util.function. This is an 8. We're in 8. Oh, it's an interface. Okay, we need a binary operator. I see. It's not abstract. Functional method is apply. Oh. Oh. Okay. I think I understand. And then composed function. Okay, we don't really want to do that. Do we need to? No. It's default. Okay. I see. So a new by function, and that has integer apply integer t, integer u. Something like this. I think these could be whatever you want, right? A, B. Hopefully, I don't know. I don't know what's gonna. I don't know what happens here. I don't know what to think of this exactly. Okay. So we're creating an anonymous class for what do you mean? What do you mean you can't find the symbol? I'm so confused. What do you mean? It's right here. Excuse me. Java.util.function. Java.util.function. Hello? Oh. I see. Really? Maybe this version of Java 8 doesn't have the function package? That's a little bit confusing. How about that? How about 15? All right, really go far into the future. What do we get if we do this? Cannot find symbol by function. Wow. What about java.util? I'm so confused. Why though? This doesn't seem to exist. I am utterly confused. Oh, my neck is aching me. Let's go back to 8. Java util function symbol not found. What is going on? Function.function. Oh. Java.u. Oh, I see. Okay. How about that? How about that? Let's see what that does. Ah, okay, that works. Okay. So this can't be used with anonymous inner classes. There we go, I see the problem. So function has, it's a package, and so you need to, okay, you need to specify it this way to get the, get all of the other pieces. Okay, and what does this look like? Cannot implement apply, attempting to reassign was public. Now it's default, right? Cannot find symbol. Subarray sum. Well, so it's not a method, but we can use dot apply. Is that what we do? Is that how we do this? Okay. That's so much effort just to get a Lambda expression like inside my, also it's interesting that this is in fact the, like you do add a colon here, semicolon. Yeah, it's all this effort just to get a function, a Lambda function in your within another function, I guess. So it's sort of like an inner function. All this effort to get an inner function. You could, I guess, create an interface for any functions you might need, and just have an apply function, and that's it. Just create an anonymous class with some interface that you create on the spot. That you'd have an inner interface, and then have an inner subclass, anonymous subclass for that interface. Just do it that way. I guess you did that way. All right, does this work? Let's see. All right, nice. Yeah. Excuse me. Okay. Neat. Well, I guess now I know how to do that. That's kind of good. You don't necessarily need to go to Java 8 for that. Better to use dynamic size arrays. Java's array list can provide you this feature. Try to solve this problem using array list. You're given n lines. Each line there are 0 or more integers. You need it to answer a few queries where you need to tell the number located in the yth position of the xth line. Take your input from system n. First line has an integer n. In each of the next n lines there will be an integer d denoting the number of integers on the line, and there will be d space separate integers in the next line. There will be an integer q denoting number of queries. Each query will consist of 2. By the way, I'm fairly certain there's a way to more efficiently solve that previous problem. I think that previous problem you might be able to solve it with a form of dynamic programming, because as you add numbers to your array, if I want to say something like, if you have a certain number of subsequences, subarrays rather, that end at that point, so they start somewhere to the left but they end at that point, and if they are, some of those are negative, then if the next number is negative, those will stay negative. Although some of those could be, the subarray sums could be less than the next negative number, or they could be negative and the next number you add doesn't make them positive, right? And so then all of those would then be negative as well. Would each of those you would have another sort of, I guess, another summoned to the total number of negative subarray sums based off of the previous ones that were negative. So yeah, I think the tricky thing with that though is that some of them might become positive and some of them not. And it's kind of hard to gauge exactly how to handle that. I don't actually know. Maybe there's like an O of n log n way to do it. Maybe you can like keep track of what all the values are, keep them in a sorted list, and then, you know, find out where in that list you should be, which things become positive, which things become negative, and just kind of go from there. Something like that. I'm not entirely sure, quite frankly. Not entirely sure how to do it, but I think there is a more efficient way to do that, to solve that problem. I think an n log n problem, but a solution, but I don't actually know. I'd have to think about it some more. I have to actually solve it. Yeah, a solution that's very similar to the longest increasing subsequence. Longest increasing, I think it's the longest increasing subsequence, yeah. Problem, a similar approach, I think could get you that count in n log n time for the number of negative contiguous subarray sums. Okay, so, or you may not even need to be that fancy either. I mean, there might be a way to do it it's even simpler than that. That's a linear. I don't know. I'm not sure. What? Excuse me. Luckily, the quadratic approach with a pre-processing step was enough. All right, first line is integer n. In each of the next n lines, there will be an integer d, denoting the number of integers on that line, and then there will be d space separated integers. In the next line, there will be an integer q, denoting the number of queries. Let's see. In the next line, there will be an integer q, denoting in the next line, there will be an integer q, denoting number of queries. Each query will consist of two integers, x and y. So the first line is integer n. In each of the next n lines, there will be an integer d, denoting the number of integers on that line. In each of the next n lines, there will be an integer d. Okay, denoting the number of integers on that line, and then there will be d space separated integers. In the next line, there will be an integer q, denoting the number of queries. A little confused. So, there's n lines, d, number of integers on that line, and then after all of those, there'll be another integer q, which is the number of queries, each query. A little bit confusing, but I remember that was the thing with Hackerrank. Like, it was, they let you write the parsing code, so it was always like really confusing to try to figure out what they were even asking, because you're like, what? How do I get the input? Each number will fit in an assigned integer. Total number of integers in n will not cross 100,000. Okay, I think I understand what's happening here. So basically, this is a matrix of values. Need to tell the number located in the yth position of the xth line. Okay, I think I understand. So x is the row and y is the column. Excuse me. Output the number located in this position. If there is no such position, print error. Okay. And those are all the queries. All right, I think I understand. Just trying to follow. So scanner. System.in. We're going to say int n equals sc.nextInt. Say for int I equals 0, I is less than n. Increment I, and we're going to say d equals sc.nextInt, int j equals 0, j is less than d, plus d, or j rather. Say next val, or val. So the way we want to do this is we have a list of lists of integers. I'll say array, and we're going to say new array list of a list of integers. And we're going to say D, we're going to say array list, or list array list. New array. And we're going to say new array dot add. I think I get the point that we don't necessarily know how big these arrays are supposed to be. I mean, you could set your array to be of size D, and this could just be a list of integer arrays, but we're not going to do that. And then at the end of that, we take our array and we add our new array. And then we're going to say parse and store the input. This is process the following queries. Q equals sc.newInt, or nextInt rather, excuse me, not newInt. Okay. Yeah. And we're going to say int A, B, no formatting checks whatsoever, And now we say if. So really it's row column, we're going to say, so X is the row and Y is the column, right? I think that's what's being suggested over here. The xth line is the row and the yth position is the column, yeah, so row column. And then we're going to say if row is less than array dot size. Then we're going to say array, or just list, integer, it's really a reference, row, or row array, or something, row array, is going to be array.get row, and if column is less than row array.size, then system.out.println, it's going to be row array.get column, otherwise can actually do something like string print or ret or result. Let's do it that way. I like this better. Row array.get column, it's going to be string value of something like this. I think it's actually integer value of, and you give it a string. So string is, it's really just toString at this point, I think. Yeah, there's like another convert to string method, I think. It escapes me at the moment. Okay, how about this? aside from the toString method, there's another way. Integer toString. There's that too. Well, yeah, okay. Wrong answer. Huh. What? I'm sorry, what's going on here? This doesn't work? Really? We never enter that. What? Are these the right indices? Oh, I think we have to subtract 1. That might be why. 0 indexed and 1 indexed. That's kind of annoying. There we go. Is it correct though? Let's find out. Hey, got there. Sweet. Okay. What am I missing though? And how are we doing on time? Yeah, approaching an hour. Okay. I only want to spend like an hour. Got another 20 problems left. What was I going to say about this? Yeah, the toString is fine. Well, this is an integer object, so the toString is appropriate here. But you could actually put this, make this integer, and then if you have an int primitive, you could put the int primitive there too. That also works. Yeah, the toString is, I think, the way to go. Okay, I guess we'll end here. I wasn't trying to spend too much time on these things. I just wanted to spend another hour. Like, we're getting pretty close. Got another 20 problems here. Maybe we can do another one. Let's see. Maybe not. The thing with arrays, it's like it gets kind of, can get kind of involved, I guess. Yeah, all right, maybe not. So this is a medium. Have to emulate a game. Okay, that's all right. We don't have to do that. Let's go ahead and end here. Yeah, got another 20 questions. That's fine. I have an interview tomorrow, so we'll see how all that goes. There's still some things I want to study tomorrow. A couple of things, like spend a little bit of time before in the morning, getting prepped for those interviews, and then I guess after that, it's only going to be 3 hours or so, I think. I don't remember exactly how long. It's not that long, 3-4 hours. I think probably 4 hours. I think it's more like 4 hours. But yeah, I don't know if I want to what I want to do in the morning. I'll have a few hours, and then have the interview. And that'll be interesting. I'm tempted to not do very much programming in the morning, only because I don't want to be worn out for later in the day. Yeah, so we'll see how all of that goes. I don't know. I also don't want to waste the time either. Like, maybe I could just read the Bible. Reading the Bible is great, but it is actually like effort. Like, that's not necessarily as relaxing as I'd like it to be. So I don't know. I think I want to Sorry, I'm just thinking. So, forgive me. My mind is kind of just because it was not a long day, but just a lot to think about. Not a lot. I don't know what to say. It's just interviewing. There's always like this element of like you wonder if you should have said something different, or should have said something else, or could have added things, or not said things, or that kind of stuff. Because ultimately, like it's extremely subjective. Sort of very initial initial interviews. Yeah, I really have to. You got to kind of sell yourself, and it's something that I struggle with quite a bit. Of like, I don't know, just doing it correctly, so to speak, or doing it well. Something of a skill that it's not really well developed for me. So I'm thinking about it a lot. Or recently, I'm thinking about it quite a bit. Anyway, yeah. So the deal is, I don't know what's wrong with me. I don't know. Guess I'm ready for bed. I don't know what I'm gonna do tomorrow. Bottom line, I don't know. I'll probably just solve some of these problems. These aren't that hard, but I expect technical interviews are always challenging though. They're not usually not that easy. I don't know what else to say or what to do. I'll probably end up solving these problems tomorrow. I don't know what I'm doing tomorrow exactly. I mean, I have the interview probably before the interview because it's later in the day. I probably will want to solve some problems, and then after the interview, I think later in the day also probably want to solve some problems. Yeah, I don't know. Just kind of keep going, keep trying. I don't know, man. My life is like it's all over the place. It's tough. It's difficult. I should do a project in Ruby on Rails. I was thinking about. Okay, I'm kind of rambling on now. Let me just go. There's a project I want to put together in the future, and I was thinking it actually would be a good idea to use Ruby on Rails for the back end. But yeah, I wanted to build like a small website, something really, really simple, and put like a chess playing bot on it, and you could make an account and do authentication and verification, kind of. Maybe not verification, but authentication. Well, yeah, I guess two-factor authentication kind of thing. And then you have an account, and then you can play against a chess bot that I will look to build. And then it's like I can kind of show off a whole bunch of different things and practice a bunch of different things and all that. Probably use the thing is Ruby on Rails is I think it's a backend framework. I don't know if you can mix and match a front end framework and a back end framework. I actually don't know how much. I think Ruby on Rails. I have to look into it. I don't know if how much it affects the front end, because technically you can, if you're only using Ruby on Rails to serve the web pages, then really you could do a lot of different things, I guess. I don't actually know. I'm thinking about it. Like I want to have probably a React front end, and then try to maybe do I don't know what backend to use exactly. I don't know. Like, I guess I'd probably want to serve a server to serve, like an Nginx or something to serve the web page, but you want like a backend framework. So I don't actually know how those things connect to each other, like a backend framework and something like Nginx. Like I don't know if one replaces the other, or if they could work simultaneously together, like supporting each other and anything like that. I don't actually know how all that works. Not super familiar with like backend framework development, I guess, if that makes sense. Just something that I feel like I should know more about that. So hence why I kind of want to build a small project like that, so that way I could show it off to employers and say like, here you go, I made this. What do you think? Hire me. Yeah, I don't know if I'm going to be working on that anytime soon, though. I think I'll probably do that I don't know if I'm doing that anytime soon. I'll probably do that sometime in the future, but I really do want to practice more like algorithm questions, and I want to practice more algorithm questions, and I want to get a job, and I feel like I should be focusing more on that than trying to build a project. But the thing is, like, if I build a project, it'll be a lot easier for me to pick up interviews. Like, you can get yourself into first round interviews, but like, if you can make your first round interview rate passing that like 95%, then I think it's a lot easier to get a job, because once you pass that, then the other steps I think tend to be a little bit easier, because they're not like arbitrary. They're kind of like, okay, can you program and can you program what we ask you to do? And usually it's like data structures, algorithms, questions, and that's something I'm familiar with, something I have a lot of experience with and practice with. So for me, the first round is usually the hardest thing. So I really just need like one small project and then I'm on my way, kind of a thing. I think for a lot of people that's the case. The coding questions, they tend to be not too difficult, and they also tend to be like kind of random. Like if it's something you've practiced or seen before, then you should be fine usually. There really aren't that many questions that people use for interviews. I mean, it's a lot. There are a lot. I mean, there are thousands, but like, it's only a few thousand, right? Like, it's actually not that much, after all. And a lot. And I guess what I really want to say is, like, it's not just that there are like only a few thousand. So that a lot of those questions are very similar. Like, they all kind of fall into similar categories for the most part. And those are kind of the only kinds of questions they realistically can ask you, because everything else would be kind of outside the scope of what's relevant or meaningful to ask. That's kind of the deal, is that like you really don't need to know all of those thousands of questions, I think, to pass that portion too. So there's that also. I think if they ask you like really hard questions, then you might need to be like, competitive programmer type of person who's like really practiced. I said I was gonna stop streaming a while ago. Let me get off here. I'm sorry. I'm rambling. I'm just going off on a tangent. But yeah, if you are there is that kind of, I've seen that kind of style of interview where they will ask you something that's like more of like a competitive programmer would know the answers and solutions, and things like Diophantine equations, if you're familiar with those, or Diophantine solutions, we'll say. Those are not things that are like even necessarily in a computer science curriculum. I would argue most of what programmers do, though, really wouldn't be found in a computer science curriculum. So there's that too. So I don't even think computer science curriculum is really all that helpful for getting a job, quite frankly, which is kind of sad, kind of frustrating, because I was told when I was a kid to do well in school and then go to university and do well in university, otherwise you won't get a job. And that basically turned out to just be a fraud. Like, really, I should have just been trying to get a job when I was like 16 and just been going from there, and I would have been fine. I would have been doing a lot better than I'm doing now, really. But that's okay. It's not, no reason to be too upset about that or frustrated about that. It's just is what it is. Would have been a lot further, a lot sooner if I had a little bit more mentorship and a little bit more focus on getting a job. Not really as focused on like just trying to get through school, that was crazy. That was insane, man. I had such a hard time in school, and just a hard time in general in so many different ways. But anyway, let me not keep going on and on. That for reasons that didn't even have, by the way, reasons that didn't necessarily have anything to do with school. I mean, I was working full time to pay rent while also going to school. And it wasn't easy, man. It just wasn't easy. I mean, I thought that I couldn't get a job without a degree. So I spent many years just waiting to get my degree, which ended up being like a horrific waste of time, which is sad. But again, like a little bit of guidance, someone could have told me, no, you could have gotten a job when you were 18, man. Like, you don't need the things that they tell you that you need are not really entirely true. You just need to be able to do the job. You need to be able to get hired, whatever that looks like, whatever that is. So anyway, all right, let me go. Yeah. thank you for watching. Talk to you soon. Have a good rest of your night. And yeah, I guess we'll see what we do tomorrow. We'll see. Okay. Take care.